brain scans revealed something disturbing. The moment before someone acts brave looks almost identical to the moment before someone panics and freezes. The difference between a hero and a bystander isn't character, isn't training, isn't willpower. It's a single neurochemical event that fires in under 2 seconds. And most people have no idea they're sabotaging it before it even begins. Let's slow it down to the millisecond. At time 0, your amygdala, 2 almond-shaped clusters buried deep in your temporal lobes, fires a threat signal. This happens before you're consciously aware anything is wrong. In brain imaging studies at New York University, researchers found the amygdala responds to danger cues in as little as 120 milliseconds, a third of an eye blink. Your body reacts instantly. Cortisol floods your bloodstream. Your heart rate spikes by 15 to 30 beats per minute. Blood redirects from your digestive system to your legs and arms. Your pupils dilate. Every system in your body is screaming one word: run. And here's what most people get wrong. They think courage means not feeling this. They think brave people are wired differently, that fear doesn't reach them the same way. The opposite is true. A 2010 study published in the journal Neuron put participants inside fMRI machines and had them choose whether to let a live snake move closer to their faces. The people who chose to let the snake approach didn't show less amygdala activation. They showed more activation in a completely different region, the subgenual anterior cingulate cortex, or SGACC. That's the key. Courage isn't the absence of the fear signal. It's a second signal that overrides it. Now we're at roughly 400 milliseconds. Your prefrontal cortex, the part of the brain responsible for planning, identity, and future projection, starts receiving the fear data. And this is where the fork appears. Your brain runs a brutally fast cost-benefit analysis. But it's not rational. It's emotional. It asks one question that most neuroscientists now believe determines everything. Who am I if I don't act? That question changes the math entirely. Because the brain doesn't just calculate physical risk. It calculates identity cost. The firefighter doesn't run into the building because she isn't afraid. She runs in because not running would damage something more important to her than safety, her sense of self. This is what researchers at the Weizmann Institute in Israel called the courage computation. They found that when someone perceives a threat but acts anyway, the SGAC literally suppresses the amygdala's retreat command. It doesn't delete the fear, it vetoes it. We're now at 800 milliseconds. Half the window is gone, your body is still in full alarm. Cortisol is peaking, your hands may be trembling, but your prefrontal cortex has made a preliminary decision, and now something remarkable happens. Your brain releases a small but critical burst of dopamine, not the reward dopamine you get from food or social media. This is anticipatory dopamine, the kind associated with meaning and agency. It's the neurochemical signature of choosing to move toward what frightens you. This is the feeling people describe after the fact as clarity, that strange calm that soldiers, activists, and whistleblowers report in the moment of decision. It's not calm at all, physiologically. Your heart is still pounding, your muscles are still flooded with adrenaline, but the dopamine reframes the arousal. The same physical sensations that meant danger now mean purpose. At 1.2 seconds, motor planning begins. Your supplementary motor area fires, preparing the specific muscles needed for the action your prefrontal cortex has chosen. And at 1.6 seconds, the full window, voluntary movement initiates. You step forward, you open your mouth, you reach out your hand, the decision is made. But here's the part that should change how you think about courage forever. That 1.6-second window isn't fixed, it's trainable. Every time you choose to act through fear, the neural pathway from SGACC override to motor execution gets faster and stronger. The myelin sheath around those axons thickens, making the signal travel quicker next time. Courage, neurologically, is a skill. The first time you push through that window, it takes everything you have. The 10th time, it fires almost automatically. This is why small acts of courage aren't small at all. Every time you speak up in a meeting when your voice shakes, every time you have the hard conversation instead of avoiding it, every time you choose the uncertain path, you are physically remodeling your brain. You are widening that 1.6-second window. You are making the override signal louder and the retreat signal quieter. not by ignoring fear, by practicing what comes after it. The next time you feel that spike of fear and hesitation, remember, you have a window, and the more you use it, the longer it stays open. If this changed how you understand your own moments of hesitation, the next video maps what happens when that window closes and how to reopen it.